Okay, hi, this is Michael Ellis, and today we're going to be doing the making of a philosopher's stone elixir. So it's going to be making gold, basically, using the conjunction function. Okay, yeah, so anyways, the conjunction process. So, so what we're going to be doing is taking tap water, putting in copper, which is what you see before us, and then adding a little baking soda. And then we're going to boil it and let it boil, and it's going to turn into gold. So that's what happens. Anyways, so I think, anyways. It goes through various color changes and ends up with a red liquid, blood red, and sparkling gold bits floating around in it. Little flakes of gold. And that's what happens, believe it or not. So let's do our alchemy. So first we're going to add our baking soda, and we don't need a lot, just a little bit to get started. So we're going to end up... Oh, actually, we'll need a lot. We will need a lot. Just to be on the safe side, we'll add a lot. Because we want a lot of gold. We want a lot of gold. There we go. Try not to get baking soda over everything. And we have our baking soda. So let's get this heating up. So basically what's going to happen is there's going to be a lot of bubbles and yeah, and it's going to boil, and you're going to see the copper atoms going off into the water to form a colloid. And this is what happens when you boil with baking soda any metal. The ions come off, or the metal ions come off into the water, or the colloids rather. I'm not sure they're ions, but maybe they're ions, I don't know. It comes off as a colloid into the water. The baking soda basically strips the action of the carbonic acid that forms in the water after the sodium and the carbonation separates in the water, and you'll see the bubbles coming up. Basically what happens is the water acidifies, and that dissolves off molecules and atoms of the copper, or the metal that's in the water. So it basically creates a acid, and that acid then dissolves metal off into the water, and then the water becomes a colloid. So then we heat the colloid with sodium, and when that happens, it goes through the color changes, and we get our gold, because it happens with the copper and the sodium bicarbonate. So here we go. Let's get this done. Respecteth the alchemy. That's what my t-shirt says. I have a t-shirt like that. I'm not wearing it right now, but it's a pretty cool t-shirt. Kind of looks like Breaking Bad. I don't know. My brother got it for me, I think, if I remember correctly. So this is going to be a long process. It's going to take a long time, so you have to kind of respect that. It's not going to happen right away, but the color changing cycle is kind of cool to watch. So you kind of gotta respect that. It just takes a while It takes a little bit of heating, and I gotta get this plastic away from here. Yikes. That wasn't smart. And, excuse my ums. So yeah. So it just takes a long time for it to accomplish the end result. And you've got to heat it at a high heat the whole time. Otherwise, it just doesn't do anything. I don't know. Maybe a low heat would work too, but I don't know if that'll actually separate the metal and the bicarbonate. I think this just works faster at a high heat. You can see some change already taking place. You can see the bubbles on the copper. That means the copper is breathing. Which is a good sign. Yes, minerals and metals do breathe. You have to respect them as life forms that they are. They have what should I say? They have like archaea or microbes or something in them that reside, maybe even energetic life forms. Who knows what they are? But what I do know is that there's something that lives inside the metal and the minerals and the crystals that makes them their home and builds them up around themselves. So that forms the shell around them and protects them and acts as their residence, and that forms the crystal or the metal crystal or the ore, and that's what results in our beautiful, beautiful jewelry and everything that we hold dear as being valuable. So we should respect them with everything we've got and feed them and take care of them. And they are resistant to high temperatures. In fact, they love high temperatures. They won't die if you blast them with a torch. So they are obviously extremophiles, meaning that they can tolerate extreme situations like salts, acids, bases, and boiling water, and high temperatures and low temperatures, extremely low temperatures. So yeah, that's just something to note. So this is a process that takes a while. I'll pause right here and I'll come back as soon as we see some of the color changing beginning. Okay, I left a little too soon. Right now we're getting a little bit of bluish, turquoise-ish tint, almost greenish to the water solution. Well, water bicarbonate solution, and copper. So this is obviously the beginning of the copper dissociation into the solution and the transformations beginning. So far, nothing much in the way of heavy saturation with metals. But you can see right there that little, I don't know what to call it, twinkling or kind of undulations in the water. Sorry, trying to steady my hand. Those undulations in the water, or in the solution rather, tell us that there are dissolved and heated bicarbonate or sodium ions that are expanding upwards and engulfing the copper. So that's a key part to the dissociation, along with the carbonation, and etc., all that other stuff. So yeah, just a little update. Then I'll get working on the next thing, or then I'll show you when the solution is fully saturated and the color changes begin, and then I'll stop. So I'll stop right now, and then I'll come back in at every other stage in the color changes, and then the final color where we get our prize after our patience is rewarded, etc. Thanks for watching. Here's another pause. I added quite a bit more sodium bicarbonate to the solution just to get it going, baking soda. So hopefully this gets it a little more saturated with copper ions, or copper molecules, or atoms rather, depending on what is actually going on or what happens. There you can see, oh, there you go. Okay, there. Now we got a nice darker turquoise color going on. So yeah, the solution looks a little bit darker now, and we've got more bubbles coming off of the copper, bigger bubbles rather. Bigger bubbles, not more bubbles. And yeah, the solution looks a little more colorful. Definitely brighter colors. Not darker colors, sorry. Trying to do too many things at once. Take care of the dog, answer the phone, and record this video. So we have copper solution, turquoise. So we're expecting a color change to occur anytime now. So I'll put it back on pause. Hi again. Okay, so having it on high was obviously a little too much, because it started to throw off acid vapors, and that wasn't very cool. So I turned it down to medium low, and that seems to be working a lot better as far as getting the dissolving going on. So so I don't recommend you boiling it per se. Put it at more of a gestative heat, in the range of medium low, somewhere I don't know, like coffee temperature, like 200, wait, no, more like 100 degrees, 150 degrees Fahrenheit. So that would be the temperature of the water, not of the actual burner. The burner would be about the temperature of 275 degrees. Yeah, the water would be about, or the solution rather, would be about 150 to 200, somewhere in that range. Yeah, that'll keep the vapors down, and we don't want acid coming off and breathing it in because it's not pleasant, especially with copper in it. So, um, so you can see we've got a nice turquoise solution going, and the sodium came off too, so that's everywhere. And we're just waiting for the solution to start turning. Looks like we might need a little more. Well, I don't know, it's probably already saturated by now. So, I mean, if it's coming off and coating everything. So we're just waiting for the solution to turn, which obviously will take a while from now. So it's patience is the key to this process. Unless I did something I forgot that I already did when I got this to work before. So I'll pause it there and wait. And to note the white powder that's falling off the copper, it seems to be forming on the surface of the copper and then falling off, sinking down into the bottom of our beaker. Besides the blue solution, it seems to be really important to the process here. Not sure what it is exactly, but it seems important, so I just wanted to point that out. So, yeah, just wanted to point that out. Thanks. Okay, so it's kind of came to a stop, the experiment. So I'm putting in an iron nail to see what happens. It's ungalvanized, just to make that clear. And I don't know. It seems like the right thing to do, because I got this experiment to work before, but I kind of have a foggy memory of it, so I'm not too sure what caused it to work. It might have been iron contamination. That's the only thing I can think of. Because I know I used baking soda and copper, and I know I supersaturated the solution, and I know I boiled it, but that was pretty much all I did. I don't know what else was in the solution that actually caused it to go through the color changes and then turn into gold. So I'm thinking iron contamination might have reacted with it. So I'm going to try this and see how it goes. So we have the blue solution. That's a plus. That means we have our copper in the solution. We have the salts. We have the white powder. That's new. I don't know what that is, but that might have something to do with the blue solution. So I'm going to add iron in and see what happens. But I know the last time, or the time I did this when it worked, I had a whole lot of baking soda in there. So, but the fact that it's already saturated, I don't know. Maybe I just need to add more baking soda. But I'm going to try the iron first. Putting the copper through a high temperature with the baking soda seemed to kind of wake it up a little bit. So I'm going to try putting the iron nail through a high temperature phase to see if that will get it to start dissolving into the solution as well. So I'm gonna try that, see if it wakes it up, gets it kind of forming little characters like you see on the. Look at that guy's holding a hammer. See the guy's face, his body, and he's holding a hammer. Isn't that cool? Anyways, so yeah. So I'll see if this puts it through and gets it going. Otherwise, then I'm just gonna add more baking soda to it, and because it shouldn't be taking this long. I think I might have hit a mistake. I think I just didn't add enough baking soda to begin with, because I think I just had a ton in there, so it might not be acidic enough to get going. I might not have enough carbonation or something. I don't know, something's wrong with it. It's not working. So I'll check back later. Here you can see bubbles coming off of the nail as we expected, or the iron rather. So yeah, it's waking up definitely. That means it's breathing, so, or it's starting to dissolve if you're more scientific minded. So so yeah. So we got the iron breathing, and now we just have to wait to see what happens with the solution. I don't know, there aren't really any color changes happening quite yet, but we'll see about that a little bit later.